In today's world of internet espionage, fraud, and data theft, the only defense we have from anyone intent on accessing our data is some form of encryption. Unfortunately, current encryption methods are inadequate. Using networks of computers, attacks orchestrated by hackers have managed to defeat most approved encryption systems. And then there are the supercomputers available to government security agencies. One thing common to all forms of encryption is the requirement of keys. Until LodeStar encryption came along, keys were always composed of binary digits in predefined fixed lengths. This remains an extremely significant weakness. LodeStar encryption solves this issue in a new and unique way. It uses real numbers. It accomplishes this by using multiple-dimensional linear mathematics in hyperspace. This may sound a bit like science fiction, but it isn't. Don't worry, the following explanation won't go into the unlimited dimensions LodeStar encryption employs to do its work. Instead, I'm going to use something very familiar for our analogy. A key, or more accurately, a whole bunch of keys. If we examine the locks we have on our doors, windows, or suitcases, they each require a special key. These keys have a number of bumps on them. For example, a 5-lever lock uses 5 bumps, or, translated into computer terms, 5 bits. With computer encryption, we may have a key length of, say, 128 bits, or perhaps 512 bits, or some other length. The key point here is that the key is always a fixed length, and just like when cracking a real lock, for the hacker, it becomes a whole lot easier knowing the number of levers used. All current encryption systems announce the numbers of levers, or bits, in their keys. This gives the attacker a great deal of useful information. As I said, LodeStar encryption works in a very different way. Only the actual key holder knows how big their key is. Examination of a LodeStar encryption cipher will not reveal any clues as to a key length. However, existing systems always give full and complete information about the length of their keys. Using real numbers, just like actual keys, LodeStar encryption is effectively analog. It uses bumps of varying heights. Each bump in a standard encryption key can only have 2 values, 1 or 0. This is known as binary code. LodeStar encryption has many possible values for its bumps, just like a real key. LodeStar encryption is not limited to fixed key lengths. It can operate with continuously variable height and length keys, all at the same time. Present-day encryption systems are not compatible with one another, just like the window, suitcase, and door keys. If you change your locks, you will need to update your entire system. With encryption, this involves re-encrypting your files to accommodate any new system. LodeStar encryption, on the other hand, is compatible across its entire range. You will not need to change your locks, ever. There is no reconfiguration required, as all relevant information is held in the secret key. All LodeStar keys are available at all times. The system has been designed to be future-proof. As computing power increases, LodeStar will stay in step with these improvements in the same secure way that it does now. This is because there are no practical limits on real number mathematics. With present encryption keys, one must specify at the start how many binary digits are to be used. This principal weakness, the key size being fixed, means that with inevitable improvements in computing power, the time required to crack fixed length and binary keys will continue to grow shorter. LodeStar encryption carries no information in its encrypted data telling a hacker how big or how small the key is. So any attacker coming up against a LodeStar-based system has to try every size, from 2 to quite literally infinity, which would take a very, very long time. It really is as simple as that. Whether in transit or at rest, all digital data can be encrypted using LodeStar. Remote cloud type storage, commercial, industrial, along with classified data, mobile telephone, internet communications, digital audio and video, or just files on a hard disk. In fact, any and all data needing protection in the digital domain. The underlying mathematics of the LodeStar algorithm would seem far less complex once the multidimensional theme was understood. It is also worth noting that our brief look at this important use of LodeStar does not go into the theory or provide any details as to the many other soft and hardware applications of the core LodeStar engine. Finally, the software footprint of a basic LodeStar engine can be made very small, making LodeStar encryption ideal for inclusion in hardware products such as smartphones, swipe or chip-based cards, and so on. Properly used, with key integrity maintained, a LodeStar encrypted cipher is demonstrably as close to unbreakable as is possible now or at any future time. Thank you.